This video will be 9.4 direct variation from our textbook. Direct variation. A direct variation is a relationship in which the ratio of y to x is constant. M, we say y varies directly with x, so the equation or symbols we're using for direct variation are y equals mx. Also, y over x is equal to m. Please note that the difference between the slope-intercept form is that, and direct variation is that slope-intercept form has a constant and direct variation does not. Alright, so just a quick few notes I wrote down for direct variation. When you see direct variation on a line, when you look at a graph, if it is a direct variation, it'll be a straight line or linear, and it'll also go through the origin. So those are the two things that need to happen in order for it to be a direct variation. Also note that y over x, the ratio of y over x is going to be constant. The constant of variation is the slope of a direct variation, so slope being m. Alright, example 1. It says the graph shows the cost of different amounts of trail mix. Determine if the relationship between the cost and the weight of the mix is a direct variation. So we could already tell that it is because it is a straight line and it passes through the origin. But we're going to check using ratios. So first let's identify a few of the ordered pairs. First one is 4, 14, which is this point here. Next point that I see here is 8, 28. And the third point here is 12, 42. Sorry, 42. So let's look at their ratios. So first we'll divide 14 divided by 4. And to find the unit rate, we divide by 4. And we get 4 divided by 4 is 1. 14 divided by 4 is 3.5. So let's see what the ratio will be for 28 and 8. So I'll write 28 divided by 8. And when you divide this by 8, you get 1. And my numerator, 28 divided by 8, is 3.5. So far these are they are the same. One more, we have 42 divided by 12. We'll divide the numerator and denominator by 12. The denominator we get 1. 42 divided by 12 is 3.5. So we see that it is constant. It is 3.5 over 1 no matter what we divide here for which point. So we can say that it is a direct variation. Okay. Example 2. Example 2, they give us the equation. The equation y equals 40x represents the distance y in miles and ostrich can travel x hours. Determine whether there is a constant of variation. If so, explain what it represents. So we have they give us the equation y equals 40x, and much like in the first example, we want to have the ratio y over x, because if we can have the ratio y over x, then whatever that number that y over x is equal to, that'll be my constant of variation or my slope of the direct variation. So if we divide both sides by x, we get y over x equals 40. And here we can see that 40 is the constant of variation. Constant of variation is 40, and then we can interpret this by saying that the ostrich can run 40 miles in 1 hour. Alright, example 3. Example 3 states the time it takes to burn amounts of information on a CD varies directly with the amount of information. Write and solve an equation to find how long it will take to fill a 700 megabyte CD. So the first thing we have to do is find the direct variation, or find the constant of variation here. Basically, we're going to let x equal time, and we'll let y equal megabytes. So we have our equation y equals mx. So to find m, I can plug in any set of ordered pairs here. I'll go with 125. So 100 would be my time, which is time should be y. This is backwards. So we're gonna go back here, let y equal time, and let x equal megabytes. So 100 is my time, so I'll plug in 100 equal to, I don't know what my slope or m is yet, so I'm going to write m. It's not a negative. And our x at 100 is 25. To solve, we divide. So divide by 25, divide by 25. We get 4 is equal to m. So now that I know my constant of variation is 4, or my slope is 4, I can write my equation again. I know m equals 4. X would be 700 megabytes. So I'll write 700 for x. And I want to know how much time it will take. When we multiply, we get y equals 2800. And therefore, it will take 2,800 seconds to fill a 700 megabyte CD. Alright, example 4 says the equation y equals 1.5x represents the relationship between the amount of heartbeats y and the time in seconds x for a dog. The graph shows the heartbeats for a cat. Which animal has a faster heart rate? So to identify the heart rate of the dog, we'll take the equation that they give us, and I know that m is my direct variation. So if I divide by x, I get y over x equals 1.5. I can also say that m equals 1.5. So now to find for the cat, I can start with the equation, and now I can plug in any of these points. I'm going to go with 3, 6. So 6 equals m times 3. 3 for x, 6 for y. Divided by 3, divided by 3. 6 divided by 3 is 2. So here I can see that the cat's rate is 2 heartbeats per second, while the dog's is 1.5. So I can say therefore the cat has the faster heart beat right? And we know that because 2 is greater than 1.5. Alright, thanks for watching. That concludes this recording.